Hey Lex, here comes the assignment that you asked me for. Let me start off by saying number 6, I ended up getting some really weird numbers too, so I have a funny feeling that the problem was copied down incorrectly, so if you want to email that back to me, I will do it. I ended up getting 59 over 23 as one of the answers, and I'm pretty sure that's not correct. So let's take a look at this. Right now, your concept that you're doing right now is called a quadratic system, and you're just trying to find the points of intersection between whatever graph the top is and whatever graph the bottom is. And so it looks like the top, I'm just going to go ahead and go through this real quickly. The top is a line, and the bottom is a parabola. And so when we look at the graphs of, like, say, a parabola, let's take a look at any parabola like that, and any line, typically there's going to be about 2 points of intersection as long as they intersect. So you should expect to have 2 different answers, all right, in this problem. So let's go ahead and see what this is going to turn out to look like. Let me erase this junk real quick. Okay, so what I'm going to do here is I'm going to actually go ahead and use some substitution because there's nothing that I can eliminate here besides the y's, and that's going to kind of make it a little messy. So I'm going to go ahead and say y equals negative 3x plus 6. And I did that by subtracting 3x from both sides. All right? And so what I'm going to do is I'm going to take that value, I'm going to pump it into this y here. So what I get is x squared equals 4x plus my new y is negative 3x plus 6. And now I can go ahead and combine some like terms here. So x squared equals, those are going to combine to become positive x plus 6. Whenever I have a quadratic, which is a squared, a linear, and a constant, I'm going to go ahead and set it equal to 0. So what I get is x squared minus x minus 6 equals 0. And then I can factor that. And so I get x minus 3 times x plus 2, which means that x equals 3 and negative 2. Now, this is where students start to get a little bit confused and they start to make some mistakes. You have to plug each of these into one of the original equations. So what I tell my students to do is I say, okay, make a situation for when x equals 3. Well, when x equals 3, I'm going to plug it into the top. That is 3. Actually, you know what? Instead of using that, I'll use this as my plug-in equation. So I'm going to say when x equals 3, I have y equals negative 3 times 3 plus 6. Well, that's negative 9 plus 6 is negative 3. So y equals negative 3. Well, what that means is that your first point of intersection is going to be 3 comma negative 3. Okay? And now you have to do another situation when x equals negative 2. Again, I'm going to use this same top equation here. So this is y equals negative 3 times 2 plus 6, which is negative 6. Oh, I'm sorry, wait a second, I made a mistake. That is not correct. It should be negative 3 times negative 2. So that is 6 plus 6, so y should equal 12. What that means is that your second set of coordinates of intersection are negative 2, 12. And remember, in the original picture, remember when I showed you the parabola and I showed you the line? We established that there are probably 2 points of intersection. Well, these 2 points of intersection are here and here. Okay? Let me pause real quick and write down the next problem. Hold on. Alright, Lex, here comes number 2. This one should look somewhat familiar. I mean, if I gave you something like 2x minus y equals 14, and then 4x plus y equals, actually, let's make this plus, equals, say, 11, you would know to eliminate the y's, right, because they have enough in common. However, one of them, remember from Algebra 1, I told you some of them need an extra little push to get there? Well, remember how we would multiply this by negative 1 to get, multiply it by negative 1 to get negative 2x minus y equals negative 14. That way the y's could cancel out. I ended up with 2x equals like negative 3, blah, blah, blah. Number 2 is almost the exact same type of problem, except now we're dealing with squares. So notice how I can eliminate x squared, but it needs a little bit of a push. I'll multiply it by negative 1. That's going to get me negative x squared plus y squared equals negative 9. So now this thing is gone. So those are going to go away now. I end up with 10y squared equals 160. I can divide by 10. So that's going to get me y squared equals 16. Y is going to equal, now be careful on this, y is going to equal, when I take the square root of both sides, y is going to equal plus or minus 4. Now, I say plus or minus, and I have to emphasize the plus or minus because when we decide to plug it back into one of these equations, we have to account for y equals positive 4 and y equals negative 4. Alright, so let's account for y equals positive 4 first. So let's go ahead and pump this into the top equation. So x squared minus 4 squared equals 9. And so x squared minus 16 equals 9, x squared equals 25, and x is going to equal, when I take the square root, x is going to equal plus or minus 5. Now what that means is that your two coordinates of intersection here are going to be positive 5 comma 4 and negative 5 comma 4. And don't worry, I'm going to draw a picture of this afterwards so that you can see what kind of what this looks like. Let's see what happens here. I'm going to pump it into the same equation. X squared minus negative 4 squared equals 9. Well, negative 4 squared is still 16. Oops. So x squared equals 25, and x equals plus or minus 5 again. Well, students are kind of thrown off by this, but let's see if things can change here. That means my answers here are going to be positive 5 comma negative 4 and negative 5 comma negative 4. Well, at this point, Lex, it seems like your answers are really, really similar, but I guarantee you they're different. At this point, Lex, you should know what conic sections are, and it seems right here you're dealing with an ellipse on the top and a hyperbola on the bottom. And if we look at an ellipse looks like this. A hyperbola looks like this. They're going to intersect at 4 different spots, which are these. This right here is your 5 comma 4. The bottom is your 5 comma negative 4. Your negative 5 comma 4 is right here. And your negative 5 negative 4 is here. So hopefully that's a good visual representation of what you're actually doing. You're finding the points of intersection, and there are 4 of them because in a hyperbola and an ellipse, there tend to be 4 unless something really crazy kind of happens. So hopefully that helps out a little bit. Number 3, I think number 3 is a really evil kind of problem. So yes, it is. I'm going to save that one for the end. I'm going to jump to number 4. Number 4. Let me pause real quick. Write it down for you. Alright, Lex, I'm back. A 3x3 system. First thing I always tell students to do is I tell them to number their equations. And so what you want to do is you want to choose a variable to get rid of. So let's just get rid of y. So if I want to get rid of y, I'm going to choose equations 1 and 2 to stack up against each other. The reason why I'm doing that is because I'm trying to get these broken down into things that I'm familiar with. So I'm going to say x minus 2y plus 3z equals 4, and then x plus 2y minus z equals 0. Now I chose y because it's easy, right? These are just going to go away, and I end up with 2x plus 2z equals 4. Now I'm going to do something here, hopefully it doesn't confuse you. I'm going to divide everything by 2 so that I can reduce this. I end up with x plus z equals 2. And that's my first equation. Now, I'm going to do another one of these, but this time I'm still going to eliminate y, but I have to choose 2 different equations. I can't choose 1 and 2 anymore, but I still have to eliminate y. So why don't I choose, instead of 1 and 2, why don't I choose 1 and 3? Okay? 1 and 3. So 1 we already had. That is x minus 2y plus 3z equals 4. 3, well that equals 8, and I've got a z over here. I don't remember what the other 2 terms are. Plus x plus 2y. X plus 2y plus z. Well, notice how these are going to go away clean again. I end up with 2x plus 4z equals 12. And now I'm going to go ahead and reduce this again. I'm going to divide everything by 2 because they're all even. You don't have to, it just makes the problem easier. Working with small numbers is always easier. X plus 2z equals 6. Okay, so now that I have 2 of these 2 by 2's, I'm going to link them together and stack them on top of each other. So I end up with x plus z equals 2 from the left, and then x plus 2z equals 6 from the right. I have to eliminate another one now, so I'm going to eliminate x by multiplying the top by negative 1. So I get negative x minus z equals negative 2. This problem is actually going to come out really, really clean. Those are going to go away. I end up with z equals 4. Okay, I have z equals 4, and now I'm going to pump this back into one of these equations. The easier one would be better, so I'm going to pump it into this left one. So, x plus 4 equals 2. X is going to equal negative 2. So now I have two answers. Now I'm going to climb all the way back up to the top and pump negative 2 and 4 into one of these original three. I'm going to choose the bottom one. So x is being replaced by negative 2 plus 2y plus z, which is 4, equals 8. I'm just trying to solve for y here. That's all I'm doing. Those two are going to combine, so I get 2y equal, 2y does not equal, 2y plus 2 equals 8. I'm going to get 2y equals 6 and y equals 3. So your answer, when all is said and done, is negative 2, 3, and 4. I understand that was a little bit fast, but remember, all we did was we chose two equations, eliminated a variable. Chose two different equations, eliminated the same variable. Stacked the two 2 by 2's that resulted on top of each other, solved for one of the variables. Climb back up to the second layer, plug it back in, solve for the second variable, plug them back into the original, and solve for the third. Okay? You might want to hit rewind on that one to see if it makes more sense the second time around. That was number 4. Number 5. Number 5 is a little bit evil. Hang on. Okay, sorry. I had to see if the pen was wigging out right there. 5. 5 is evil. Actually, I'll pause real quick. Hang on. I'll write it down first. Alright, Lex, I told you this problem is evil, but it's okay. We can handle it. It's not going to be a big deal. So there are a couple things you can do. You can try and fraction bust this thing, but I decided not to. I think fractions aren't that bad once you get used to them. I'm just going to kind of do them with fractions. If it confuses you, just email me, and then I'll do it the fraction busting way. So what I'm going to do is, again, just like the last problem, I'm going to number them all. 1, 2, and 3. I have to choose a variable to get rid of. I think that z is easiest to eliminate because there's a positive 2z here and a negative 2z on bottom. So I'm going to stack 2 and 3 against each other. I need more space. So if I'm going to stack 2 and 3 against each other, I'm going to get 2 over x minus 4 over y plus 2 over z equals 20. And then I'm going to get equation 3 here, which is 4 over x plus 6 over y minus 2 over z equals negative 24. Now, one thing I want you to really notice is that even though we've got these variables in the denominator, notice how if we look from top to bottom, they all have the same denominator, right? There's no need to find a common denominator in anything here. X, 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 y, 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 z, z, z. There's not going to be a need to find a common denominator, so we're going to be good in terms of our adding and subtracting. 2 over z minus 2 over z is going to go away. 2 over x plus 4 over x is 6 over x, right? If I have 2 over x plus 4 over x, the denominators are the same, so it just becomes 6 over x. Yeah, hopefully that makes sense. And again, we got common denominators from top to bottom. Negative 4 over y plus 6 over y is plus 2 over y, and that's going to equal negative 4. Okay, box that. Okay, let's do the next one. Let's see, I'm going to choose to eliminate z again, so I'm going to go ahead and choose numbers 1 and 3. Okay. So this is going to be 2 over x plus 6 over y plus 8 over z equals 12. And then 3, can't change colors there, sorry, 4 over x plus 6 over y minus 2 over z equals negative 24. This one's going to be a little harder because one of them needs a push. So what I'm going to do is I'm going to multiply the whole top by 4. Okay? Because that way this thing can become negative 8 over z. So then I need to rewrite this. This is going to be 16 over x plus 24 over y minus 8 over z equals negative 96. Okay, that's what happens when I multiply all of these things in. So I'm going to go and erase some stuff here. So these are the two equations that I have stacked on top of each other. Notice how those are going to go away. Now I have to add downward. This is going to be 18 over x plus 30 over y equals 12 minus 96, that is 84, which is negative. Oops. Okay, so now the concept is still the same. I'm going to stack the two boxed equations against each other. So it's going to be 6 over x plus 2 over y equals negative 4. And then 18 over x plus 30 over y equals negative 84. Okay, again, the top is going to need a bit of a push. I'm going to multiply it by a negative 3. So I get negative 18 over x minus 6 over y equals 12. And I did that so that I could eliminate the 18 over x's. So I end up with 24 over y equals negative 84 plus 12 is going to 84 minus 12, that's going to be a negative number, so 72. So now I'm going to go ahead and cross multiply these. Let's see, it looks like y is going to equal, negative 72y is going to equal 24, y is going to equal negative 1/3. Okay? Alright, Lex, I need to pause and clean this up for a second. Hang on. 6 over x plus 2 over negative 1/3 equals negative 4. And so I'm going to simplify this. 2 times negative 3 over 1. Sorry, one of my students walked in and distracted me. 2 divided by negative 1/3 is really 2 times negative 3 over 1. So that is negative 6. So 6 over x minus 6 equals negative 4. So we get 6 over x equals negative 2. Positive 2. Now I'm going to cross multiply that. So I get 2x equals 6, x equals 1/3. Okay, let me pause real quick and clean all this up. Okay, the last thing we're going to do is we're going to take these two answers and we're going to plug them into one of these originals. So I'll just go ahead and choose the top one. So I'm going to get 2 over x. Well, x is 1/3 plus 6 over negative 1/3 plus 8 over z equals 12. These are going to simplify into a 6, negative 18, and a plus 8 over z equals 12. These are going to be negative 12 plus 8 over z equals 12. I got to kind of speed through this. 8 over z equals 24. Cross multiply again. 24z equals 8, and z should equal 1/3. So your final answers are 1/3, negative 1/3, and 1/3. Kind of a cool problem. We don't see much of these types in our current book. Okay. All right, here comes problem 3, the evil problem. First thing I'm going to do is I'm going to get y by itself. So I'm going to go ahead and divide x out. So I'm going to get y equals 12 over x. And then from here, class, does it make sense that we're going to substitute that into y right here? Yeah. So we're going to get 4x squared minus 12 over x squared equals 20. So then this becomes 4x squared minus 144 over x squared equals 20. I need a common denominator. Hey, what's the common denominator here between all these three terms? X squared, right? X squared, and x squared. So what I get here is 4x to the fourth over x squared. Actually, no, minus 144. I'm sorry, this one didn't need it. Over x squared equals 20x squared over x squared. Got to establish something in our domain. What can't x equal since I have an x in the denominator? Can't equal 0. Okay, so I got to make sure I keep that in mind. Okay, so now I am going to go ahead and cancel all those out. I'm going to go and say 4x to the fourth minus 144 equals 20x squared. I'm going to subtract 20x squared from both sides. So that's going to be 4x to the fourth minus 20x squared minus 144. From here, I can go ahead and factor out a 4. So I get x to the fourth minus 5x squared minus 36 equals 0. So let me go ahead and copy that over. Okay, and then I'm going to go ahead and move some of this junk. Alright, so I can eliminate that and paste the other thing back in. Darn it. Lost it. That's okay. It's actually 4 parentheses x to the fourth minus 5x squared minus 36 equals 0. Okay. Raise your hands if you know how to factor the inside. How do you factor the inside? Alan, what do you got? X squared plus 4. Okay, here's why this problem is difficult and evil. Here, we know that x equals plus or minus 3. That's where this equals. Can this right term, can it be factored and solved at all? No, I end up getting x equals, if I really wanted to force solve it, I get plus or minus 2i, right? And I is what type of number? Imaginary. So imaginary intercepts don't exist, so this one's out. All I have is x equals plus or minus 3. Now from here, the second equation was xy equals 12. So now I have to create a situation when x equals 3. When x equaled 3, that was 3y equals 12, y equaled 4. So the first points of intersection are 3, 4. And then the next one is when x equaled negative 3. So negative 3y equals 12, y equals negative 4. So my last point of intersection is going to be negative 3, negative 4. So the evil part about this problem is that you got to make sure that you don't include the imaginary intercepts. Cool. See you later.